Let's talk about compound inequalities. Just like with the English language, if we talk about a compound sentence, we have like two complete parts, and those are joined by words like and, or but. With math, when we have compound inequalities, we have two complete inequalities that are joined by an and or an or. The and is not always explicitly stated. It is sometimes implied. So I have a couple examples here. In this first one, it is -3 is less than 2x plus 5 is less than or equal to 7. That's a compound inequality with an implied and statement, because what it's saying is -3 is less than 2x plus 5, and by the way, 2x plus 5 is also less than or equal to 7. So do I have to split it apart and do two separate problems? No, I am always going to tell you to take the shortcut when you can if it's mathematically legitimate. So I would leave it exactly as it's written, and just remember that as I'm solving, whatever I do there in the middle, I need to be consistent and do that on both sides so that everybody stays the same. So normally if I'm solving 2x plus 5 for x, I would subtract 5. So you see I've subtracted it from all three sections here. And don't worry about that. So now I have -8 is less than 2x is less than or equal to 2. Well, I want to solve for x, so I'm going to have to divide. Again, I divide all three sections exactly the same, and I get -4 is less than x is less than or equal to 1. X is trapped in the middle. It's between those two numbers. So my interval or my graph kind of just pops out at me, right? It's X has to be in between those things. So I have -4 to 1 is my interval. I have -4 is less than, strictly less than the X. So I'm going to use a parenthesis to show that it doesn't include that endpoint. But on the 1, it says X is less than or equal to 1. So if I want to indicate that the endpoint is included, I use that bracket notation, okay? And then similarly, my graph is going to just be shaded between those two numbers. Same notation, parenthesis on the -4, a bracket on the 1. My second example over here is an explicit statement. It says this or this. Well, in those cases, you actually do solve two separate problems. These are pretty quick solves, and we get two separate statements. Now listen carefully. If you have an or statement, it's going to be extremely rare that you can mush that into one statement. You're going to keep that as two separate pieces, and if you have two separate pieces, you're going to have two separate intervals, you're going to have two separate sections graphed on your number line. Okay, so the ors almost exclusively, not 100%, but almost exclusively, especially for our work, two separate things. The ands, where it's that long string, is usually just going to be one little single segment of the number line, one single interval, right? So if you have x is less than or equal to -1 or x is greater than 3, those are mutually exclusive. You can't be in both camps. So I have two separate intervals, and then when I look at the number line, it's the same thing, two separate sections on the number line. Here are two more examples. Very quickly, this is an or. So again, two separate pieces. I get two separate inequality answers, right? So the inequality notation, two separate sections on my graph, and two separate intervals, right? So inequality with those little arrowy things, graph on the number line, interval with the parentheses and bracket stuff. Okay, and remember that U just means union. It's this or this. This last example is a little bit tricky, and I want to just point out that as you're solving it, you're doing the same thing to all three sections. We're subtracting 6, we're dividing by -2, but oh wait, dividing by -2, that means we flip that inequality, remember? So notice they go from less thans to greater thans. That's true. 5 is greater than or equal to x is greater than -4, but that's not how it shows up on the number line. So normally we want to start a string inequality with the smaller number. So we pick it up and flip it over and start with the -4 and kind of read this backwards. So -4 is less than the x is less than or equal to the 5. And same thing on the graph, then we're going to be trapped in between the -4 and 5. And I look very carefully. The 4 has the strict inequality, so it's a parenthesis. We don't include the endpoint. The 5 has the or equals to, so we include the endpoint and use the bracket. Finally, that matches up with my interval answer there. Let me know if you have questions.